Hi friends, welcome back. Today we're talking about reflecting your parent functions. We're either going to be reflecting them over the x-axis or over the y-axis. So let's talk about what that looks like. All right, make sure you grab your notebook, write this down. I swear you're going to be much happier if you write these notes down because instead of trying to take a picture of them or screenshotting it, things like that, you don't want to do that. You actually want to physically write it down because you will have a much better chance of remembering them if you write it down. So what this says is if we take our function and we multiply the whole function by -1, or have a negative on the outside, that's going to reflect over our x-axis, which means when we have our xy points, if you're reflecting over your x-axis, your y-axis or your y letter is the one that becomes the opposite. So whatever y is, we're going to do the opposite. If it's just our x is negative, that we're reflecting across the y-axis, and in that case, our x is going to be opposite. So let's talk about what that looks like. Write a function that shows a quadratic function reflected across the y-axis. Okay, well, if we have a quadratic function, f of x equals x squared. That's our quadratic function. We want to reflect it across the y-axis, so we look at our notes here and we determine that the x is negative, right? The x is negative. So this is going to become f of x equals, and you have to be careful here because you want the x to be negative, so you've got to put it in parentheses to attach it to that x. If we reflect it across the y-axis, it's the whole function that's a negative. So this one looks different. Instead of just having our x squared here, what this one would look like is it would be f of x equals negative x squared without those parentheses. So I want you to see the difference between this is the whole function being multiplied by -1. This is just your x being multiplied by -1. It's not always a negative either. There can be a number there in front of it. We talked about that in a previous video. That's the stretching and the compressing and the vertical and horizontal stretch and compress. So let's talk about this one. All right, so we've got this guy here. What is the equation of g of x in terms of f of x? So I have f of x here and I have g of x, and I look at that and I go back to my notes that I know you have written in your notebook, and you look at your parent functions and you say, oh goodness, that is a square root of x. Square root of x. Now, this is our x-axis, this is our y, and it looks like g of x has been reflected across the x-axis. So we go back and we look at our notes and we see, oh, reflecting across the x-axis means that we're making the whole function negative. So g of x would be negative square root of x. Negative square root of x. Now, what is the equation of g of x in terms of f of x? Well, f of x, or I should say g of x, let's try that again. G of x is f of x, except that we're multiplying it by the whole function, right? So it looks like this. So that would be your answer. What is g of x in terms of f of x? Let's try that again, but this time we'll use this one. Again, what is the equation of h of x in terms of f of x? So first let's figure out h of x is that same square root, except this time it's reflected across our y-axis. Remember, when we're reflecting across our y-axis, our x is negative. So in this case, we have the square root of negative x. So this is different because the square root's on the inside, or the negative's on the inside of the square root. So that means, what is the equation of h of x? Well, h of x is f of x, except the x is negative this time. So it looks like this. So you can see the difference between this guy and this guy right there. Hopefully that helps you understand reflections. If you have any questions, let your teacher know. Otherwise, we'll see you next time.